Okay, so I'd like to now invite all of the panelists up. You'll have plenty of opportunity to ask Kara and the others questions. We'll go for about a half hour. And I'd also like to, well, first of all, questions, please come up to the microphone. That'll be a more convenient format for asking questions. And as the panelists assemble, I'd like to remind you that you can get coffee tomorrow morning at 7:15. And that the session, tomorrow's session, will begin bright and early at 8 a.m. and we'll go till lunch. And I think we have Dr. Mattis for the lead-off question for the panel.
Good, thanks. So, Kara, I want to follow up. You were very clear about being science-driven, not challenging that, but you were also very clear about being pragmatic, about developing an intervention strategy that kids would resonate to and that was effective and so on. So the largest meta-analysis looking at low-calorie sweetened beverages versus water shows that low-calorie sweetened beverages are more effective than water at promoting weight loss. Now, I know there are people that have objections to the use of low-calorie sweeteners, but if we're going to be pragmatic and science-driven, that's where the evidence is right now. Wouldn't it make more sense to be more lenient towards low-calorie sweetened beverages? They probably work because they promote better adherence, right? Not magic, but that is where the science is right now.
Yeah, can you hear me? Okay, interesting that you brought that up. We actually have some unpublished data from young adults where we randomize them to an unsweetened beverage group, or water, basically, an artificially sweetened beverage group, and a sugar-sweetened beverage group. And in terms of body weight, we saw no difference between the artificially sweetened beverage group and the unsweetened beverage group. There's always concerns about other adverse effects of these sweeteners that I think comes into play. But in terms of the body weight, and you know, I guess I'm always cautious when I'm talking about the artificial sweeteners because everybody's so, their ears perk up. But indeed, in our studies with adolescents, you know, we did see a role for these diet beverages, even though we were trying to get them to the water, knowing that water, there's no question about water. Yeah.
Kara, can you say it again? You said there was no difference in weight gain between your water group and the non-caloric sweetener group? Is
yes.
That what you, okay.
Yes. We'll be sending those data for review soon. Yes.
I would like to thank all the speakers and ask Mark a question. So you spend a lot of time studying what activates CHR-ABP. And it looks like a great deal of that is through glucose 6-phosphate. So do you have evidence that glucose or fructose more potently upregulate CHR-ABP? And also, it seems like fructose is more lipogenic than glucose. Is that mediated to CHR-ABP? Or maybe, can you comment on maybe other pathways, how fructose may be more lipogenic than glucose?
Yeah, so multi-part question. I'll try to remember it all. So we published in 2016. If we take just a wild-type mouse and gavage them, well, actually, and I showed some of this data. Gavage them with water versus glucose versus fructose. Fructose alone by gavage potently, robustly activates CHR-ABP. Glucose by itself does not. However, what's also in that paper, what I didn't show is we obtained a glucokinase activator compound from Pfizer. So this is a pharmacologic that they developed when they, at the time they had the idea that giving a glucokinase activator, giving a liver glucokinase activator would increase liver glucose uptake and would be a treatment for diabetes to reduce glycemia. Now, that whole project didn't pan out because what it really did robustly was increase circulating triglycerides. Which was not a good thing. So we got this compound from Pfizer, and if we give this compound alone, that is not sufficient to activate CHRV in the liver either. But if we give the glucokinase activator and we give a bolus of glucose by gavage, then we get robust activation of CHREP in the liver. Because you need two things for glucose to activate CHRP acutely in the liver. You need glucokinase to be active, and you need the glycemia to be high enough that it's above the Km of glucokinase for glucose, which is about 8 millimolar. So it's not just fasting glycemia. You need glycemia to be elevated in the portal vein to get influx of glucose into the liver. So we see it in those two situations. Now, what I think you're interested in is chronic feeding situations where you're feeding high fructose versus high glucose diets for chronic periods of time. And so in that setting, we see in the acute refeeding state, fructose again is much more able to activate hepatic CHRP than glucose is. But if you check, for instance, in ad-lib fed animals, when an animal's been fed a high glucose diet for a very prolonged period of time and they've gotten somewhat obese, the whole body is replete with carbohydrate, and so lactate that's recirculating from the periphery to the liver is increasing the amount of glucose-6-phosphate in the liver as well. And so you see some degree of CHB activation there as well. Yeah, but still, fructose is more robust. That was a long answer to the first part, and I've forgotten the second part of your question. Yeah.
And then can that tell us why fructose may be more lipogenic than glucose?
Yeah. So again, I think there are two issues there. So one, fructose, because it's taken up more robustly by ketohexokinase than glucose, you have more substrate in the liver, so more substrate to be converted to lipid, but then it's also more potent at activating these programs. But sucrose, right, which is the combination of glucose and fructose, so now you have the substrate, plus you have glucose's effects to stimulate insulin secretion, which activates SREBP1C. So now you've got synergy from two separate inputs and two separate transcription factors, both synergizing on those lipogenic targets to potentiate lipogenesis. So I think they work together.
Hi, I had a question for Dr. Manella. I was curious if there's any evidence about the malleability of sweet preferences. So you showed, as kids get older, they prefer less and less sweet things, but I was wondering about, it relates to interventions, if there are interventions we might do to alter sweet preferences.
For the very young child, the only studies that I know of are associational, and it doesn't say cause and effect, but the earlier, just like with salt, earlier exposure, those children are preferring higher levels than those that didn't get the exposure early. You can always go up, I think, but there hasn't been a lot of interventions right on the very young child. But I think the thing for experimentally, one also has to test the child in the context of the food you're interested in. For salt, it would suggest that you'd have to, maybe to lower salt, you'd have to reduce it, all foods, rather than a specific food. But can children learn to like a food lower in sweetness? We know because of its properties for, let's say, reducing bitter, is that you can get children to like a bitter tasting food by adding sugar and then gradually reducing the sugar. But there really isn't a lot of basic research on this young preschool or infant age. It's all association, not like these elegant RCTs.
Hi, I also want to thank you for excellent talks. Two questions. One to you, Dr. Manella. Is there any effect of breastfeeding on sweet preferences over time? I mean, is anything happening because of the rates of breastfeeding are different in different societies or decreasing to sweet
No
preference?
evidence that the early mode of, let's say, breast versus formula feeding affects sweet. What it seems to affect is, depending on the taste of the infant formula, some children will like sour or bitter more if their formula tastes sour or bitter. Breast milk, the one taste that you see a difference in is more the savory, the umami taste, the taste of glutamate. There you'll see breastfed infants showing, the babies will show more hedonic response to it, but not a lot. Okay. And I think that, as we talk about, breastfeeding versus formula feeding, there are also big differences in probably the food environments of those children as well. So, great question.
Yeah.
Sorry I don't have the answer.
No problem. And just one other question, Cara, for you. You allowed either water or sugar-sweetened beverages or diet beverages, rather, in your study for the comparator. Did you break down the change in weight versus those two subgroups?
No, we didn't have the power to do that. It was something that we would have liked to take a look at. The other thing was that the groups aren't as clearly defined as you might think, with relatively
hard
few
to-
drinking exclusively water. So that posed a challenge, and that prompted us to do another study where we had 3 arms. That study hasn't been published yet, but that was sort of the impetus for that.
Great topics, everyone. I'm going to try not to be obnoxious again, but this late. But what do all of you think we need to prove in order to ban sugar-sweetened beverages, not just tax them? So I think that we have to show irrefutably that in the act of overfeeding, so, Americans are being overfed, right? And most of us think it's because of added sugar-sweetened beverages or sugar intake or whatever. I think we have to show in a controlled study that in the act of overfeeding, we're getting an outcome that is detrimental to health, such as oxidative stress or, or something that can be shown to be more detrimental in those who are obese than those who are lean. But what else? What are your thoughts?
I think it's very easily accepted, almost overly accepted, that obesity promotes metabolic disease, almost to the point that there's a lot of people who resist the idea that we should be looking at any specific culprit. Sugar is not a specific contributor to obesity, that our only problem is that we eat too much. And so I think it's our job to identify indeed whether sugar is a specific contributor, but that is not easy by one study. We're going to have to look at the totality of the evidence. We're going to have to look at the observation studies, the animal studies, and I'll just explain my 4-year learning lesson that was kind of humbling. About 4 years ago, we got an NIH grant, and I was very excited to get this grant funded because I thought it was beautifully designed. We were going to give, for a 10-week period, controlled diets to everybody, but we were going to have 4 groups. After a 2-week period in which everybody was on the identical diet, then we would randomize to high fructose corn syrup beverage, aspartame beverage, in a group that was given their meals in energy balanced amounts, and not allow that group to gain weight. The other group, though, we were going to give identical meals, but in much higher proportions, and they were going to be allowed ad lib quantities. The amount of sugar they would consume or the amount of aspartame beverage would still be identical to the other 2 groups.